Hello there, Engineering Science. It's Mr. Young here again with a quick video on parallel circuits this time. We did a quick video, or a 5-minute video before, on series circuits. So this is a lead on from that. Series circuits. It's an easy way to look at how to add resistors together in a series circuit. These become a little bit more complicated in parallel circuits. You've got two equations this time, which I'll go through both of them and try and give a little hints and tips on how this can make it easier here. So by the end of this, you'll be able to calculate a parallel circuit and recognize the different equations for each type of circuit here. Okay, it's not as complicated as it looks, but if you follow the procedures, you should be okay. Right. So resistors in parallel, again, just a little bit from before. It's just a resistor limits the flow of electric current in a circuit, so it sort of saves your lamps and LEDs from blowing. If they weren't there, they would blow. And again, we're measuring in ohms, and we've got R1 and R2. I think I missed this off in the last video, but usually they go R1, R2, R3, R4, depending on how many resistors we have in a circuit. All right, so in this case, we've got our parallel branch. You can see this time I've got a resistor here in this branch, and then a resistor in the next branch, a 50 ohm and a 50 ohm. So R1 and R2, so they're kind of linked together in the circuit in that way. Slightly different before because the series ones were just linked, just on the top and the sides around the outside of the circuit. And in this case, we've got them kind of parallel to each other. Remember, parallel means two lines and going in the same direction. In this case, it's these resistors here. Okay, so to calculate it out, we're going to use either this method here, following equation. It's good to see I've cut that off using this, but I shouldn't have copied and pasted that now actually. So two resistors in series in parallel. So RT, the total resistance, is equal to R1 times R2 divided by R1 plus R2. Okay, so we're going to go 50 times 50 divided by 50 plus 50. Okay. This only works in two resistors in parallel, okay? So if you've only got two resistors in parallel, this equation works fine. So as you can see here, what I've got here is I've got 50 multiplied by 50 divided by 50 plus 50. So that's what we said at the top line here, and then the bottom line is just adding them together, okay? So what you should have is, it should be 2500 divided by 100, all right? And then that gives you the overall resistance of this circuit is at 25 ohms. Alright, like I say, only works for two resistors in parallel there. And it's a quick way of if you've got two resistors in parallel, you can use this, and it's a quick way of dealing with that. Just remember though, when you're dealing with this, it's easy to make a mistake on your calculator. Just make sure that you do it line by line, so you know that the top branch, 50 times 50, is going to be 2500. And at the bottom branch, the bottom part of this equation is going to be 50 plus 50. So always work at these separately and divide that by that. Okay. If you're trying to do it all in one go in a calculator, you'll end up with crazy numbers. Right. The rule, it's a general rule here, and the rule is that the total resistance should always be smaller than the smallest resistor. So in this case, the smallest resistors are both the same resistance at 50. So the total resistance in this circuit should be less than 50. And in this case, it is. It's 25. Okay, we'll go through another one and we'll see if that rule holds true. And you can check as we go through these and as we go into the next ones as well in the next videos. Okay, so more than 3 parallel resistors, we're going to use, if we've got more than 3 resistors in parallel, we're going to use this equation, which is 1 over the total resistance, RT, is equal to 1 over R1, 1 over R2, etc. going on, depending on how many resistors you are. Technically, it's only hopefully going to be 3 or 4. Okay, and in this, what we're going to have to do is find out the common denominator. You know, what do these resistances all equally divide into, or resistors equally divide into, right? 2 ways of doing this, and there's an easy way and maybe not so an easy way, but it's a way of less thinking involved. But the first way is if we've got this one, we've got 3 resistors here. R1's got 2 ohms, R2's got 5 ohms, and the third resistor's got 10 ohms, okay? So if we're looking at a common denominator, what do they all equally divide into? This is where I could do my Dora bit and just wait for a second to see if you can remember or think about it. Right, still here. I just thought I'd give you a wee second there to think about it. So what do they all equally divide into? Well, they all equally divide it into 10, don't they? Which is also equal to R3. So if we look at this, so 1 over R1 plus 1 over to R2 plus 1 over R3. So what we're looking at, we're putting 10 on the bottom here because they all divide equal into 10. So 2 ohms will go into 10 5 times. Okay, so that's why we've got 5 over 10 because that's R1. R2, well that's 5 ohms in R2 there. So how many times does that go into 10? Well, if you can look at here, 5 goes into 10 twice. And if we're looking at R3, R3 is 10 ohms, right? So how many times does 10 go into 10? Once. So that's why I've got 5 over 10 plus 2 over 10 plus a tenth, right? And what we end up with, we add up the top numbers to give us 8 divided by 10. Now to get our resistance, or our total resistance in this circuit, we're going to turn the numbers upside down and divide. So 8 over 10 becomes 10 over 8, and we're going to divide that, and that gives me the total resistance of 1.25 ohms, right? Remember the total resistance should always be smaller than the smallest resistor. The smallest resistor in this case is 2 ohms. Total resistance is 1.25. So I'm pretty happy I've done that right. Okay. If that was any difference, if it was like 5 or 7 ohms, and I was looking at that circuit, I've went wrong somewhere. So always check at the end. Is your total resistance smaller than your smallest resistor? If it is, chances are you've done it right. Okay, like I said, there was 2 versions of that. That was version 1. Version 2 is it's the same circuit. Okay, but let's pretend, right? You don't know what the common denominator is. You don't know what they all divide into. Right? You're just sick, fed up. You're like, is there an easy way to do this? Well, there is. What you do is you multiply the 3 resistors together. Okay, so 2 times 5 times 10. Okay, so 2 times 5 is 10, times 10 is 100. So the bottom line in our equation now are all going to be 100. So made that 100, that's 100, that's 100. Same rule applies. 2 goes into 100 for R1. How many times? Well, in this case, 50. You can see there's a pattern here because you can check it from the one before. So 50 over 100. So R2 is 5 ohms. How many times does that go into 100? That goes into 100 20 times, right? And how many times does 10 go into 100? That goes in 10 times. Okay, so you end up with 80 over 10, or 80 over 100, sorry, that should be 100. Now turn that upside down, so 100 divided by 80, and the result ends up being the same, 1.25 ohms. Okay, it's the same, no difference. And again, the smallest resistor should always be smaller than this. Total resistance should always be smaller than the smallest resistor. Alright, so that's 2 ways. And like I said, that should be 100. It should exactly be the same as that. So it's 2 ways of doing that. Both ways equally easy, or if you're figuring it out, if you're struggling, use this way. So, recap. If there's only 2 parallel resistors, use the R1 times R2 divided by R1 plus R2, but be careful making sure you've worked out both top and bottom bits separately so you don't make a mess of the calculation. If there's more than 3 or more parallel resistors, use this method, the 1 over R1 plus 1 over R2, and find the common denominator. If you don't have one, multiply the resistors out to find a number for your bottom line. And the rule is that the total resistance should be always smaller than the smallest resistor. That's me. I hope everyone's staying safe, and thanks for watching.